Let's break down each of the key technologies driving Industry 4 and how they play a role in creating smart, interconnected production systems. Starting with IoT, which is all about connecting physical devices, which are machines, sensors, products, etc., to the internet, allowing them to collect, share, and analyze data in real time. In the Industry 4 context, IoT enables smart factories where machines and equipment communicate with each other, monitor conditions, and make adjustments autonomously. Say, for example, sensors on a production line can monitor temperature, pressure, and machine health and send this data to a central system. This allows manufacturers to optimize operations, detect issues early, and reduce downtime. This is something about IoT. Then comes up the AI and ML, which are the brains of Industry 4, allowing machines and systems to make decisions based on data. So AI can analyze vast amounts of data, identify patterns, and make predictions, which is incredibly valuable in manufacturing. Then ML goes a step further, allowing systems to learn from past experiences and improve their performance over time. So in manufacturing, AI and ML can be used for predictive maintenance, where systems can forecast when equipment is likely to fail and recommend maintenance before problems occur. They are also used in quality control, identifying defects and inconsistencies faster and more accurately than humans. Then our big data and analytics is the foundation for data-driven decision making in Industry 4. We all know that manufacturing generates huge amounts of data, be it from machines or sensors or systems. Now, big data technologies help process, analyze, and derive actionable insights from this data. Analytics helps manufacturers understand trends, optimize processes, and reduce waste. So, for example, data analytics can identify production bottlenecks or inefficiencies and recommend adjustments to streamline operations. So in the long run, this means higher quality products and lower operational costs. Then the cloud computing provides a flexible and scalable way to store, manage, and process data from anywhere. So with cloud platforms, manufacturers can store large amounts of data securely and access it in real time. This enables global operations and collaboration. So this cloud computing also allows for remote monitoring and real-time control of manufacturing processes, which is especially useful in complex multi-location operations. Manufacturers can leverage powerful computing resources without investing heavily in physical infrastructure, which is cost-effective and efficient. Autonomous robots then are the robots that can operate independently, often using AI to navigate and make decisions in real time. So in Industry 4, these robots are commonly used for tasks like assembly, packaging, warehousing, etc. So they can work alongside humans, sort of collaborative robots or cobots, or independently as well, performing repetitive or dangerous tasks with high precision and speed. The advantage of autonomous robots is their ability to adapt to different tasks and environments, making them valuable assets for improving productivity, safety, and efficiency on the production floor. Then, additive manufacturing or 3D printing is a process where materials are added layer by layer to create a physical object from a digital model. So, unlike traditional manufacturing, which involves the cutting away of the material, assembling, etc., additive manufacturing is more flexible and less wasteful. So in Industry 4, this 3D printing allows for rapid prototyping and customization of products where manufacturers can create complex designs quickly and at a lower cost, which is especially useful for creating small batches of customized products. It also enables localized production where parts can be printed on site, reducing shipping costs and production lead times. Then the augmented reality and virtual reality or AR and VR are technologies that are transforming training, maintenance, and design in Industry 4. So, AR, which is augmented reality, overlays digital information like instructions or data on the real world environment. Say, for example, technicians can use AR glasses to see step by step instructions while working on machinery, making maintenance tasks faster and reducing errors. VR or virtual reality, on the other hand, creates a fully immersive digital environment, often used for training and simulations. So, workers can practice skills in a virtual setting before applying them on the factory floor, enhancing safety and reducing the time required for training. So, together, AR and VR improve accuracy, enhance training, and streamline complex processes by providing intuitive visual information. So, all in all the key technologies are the building blocks of Industry 4, each contributing to a smarter, more flexible, and data driven manufacturing ecosystem. Let's dive into how IoT, Internet of Things, plays a central role in Industry 4. As we discussed, IoT is all about connecting physical devices and systems so they can communicate and exchange data in real time, creating an interconnected, intelligent manufacturing environment. So, at its core, IoT enables real time data exchange between machines, systems, and products. This constant flow of data allows manufacturers to make faster and more informed decisions, optimize operations, and respond to changes with agility. So, IoT is a key driver of smart factories where machines, equipment, and even inventory will communicate seamlessly to improve efficiency and reduce human intervention. So, let's take a quick look at some of the practical applications of IoT in manufacturing. Starting with the smart factories where machines equipped with sensors and IoT devices can communicate directly with each other. This connectivity allows them to share data on production status, detect bottlenecks, and adjust processes in real time. So, say for example, if a machine detects that it is close to overheating, it can send an alert or automatically adjust its operation to avoid downtime. This type of automated self-optimizing production reduces the need for human intervention and boosts productivity. So smart factories are also more flexible. They can switch between production tasks easily and respond quickly to changes in demand, which is particularly useful in industries that need to adapt to custom orders or fast-paced markets. Second is the asset tracking. So IoT makes it impossible to track assets in real time. IoT makes it possible to track assets in real time across the supply chain from raw materials to finished products. IoT-enabled tracking devices provide updates on the location, status, and condition of goods, ensuring that manufacturers have complete visibility into their inventory. Say, for instance, RFID tags or GPS trackers can be attached to shipments, pallets, or even individual items. This data helps manufacturers and suppliers know exactly where their assets are, preventing losses and delays. Real-time tracking also allows for better supply chain planning, where manufacturers can anticipate delays or shortages, plan around them, and reduce lead times. Finally, remote monitoring is a major benefit of IoT, allowing manufacturers to keep an eye on equipment performance from anywhere. So, IoT sensors collect data on critical metrics, be it vibration, be it pressure, etc., which can indicate the health of the machines. With real-time monitoring, manufacturers can respond proactively to issues instead of waiting for a failure to occur. If a machine starts showing signs of wear, a technician can be alerted to check on it before it breaks down. This practice, called predictive maintenance, helps avoid costly downtime and extends equipment life. So, in addition to equipment monitoring, remote monitoring also benefits quality control. IoT devices can track environmental factors like humidity or temperature that affect product quality, allowing adjustments to be made instantly if something goes out of range. All in all, IoT's ability to collect and share real-time data empowers manufacturers to run leaner, more efficient operations. Then we have our artificial intelligence and machine learning, and they are incredibly transforming Industry 4.0. Both these technologies drive intelligent decision making and automation, enabling manufacturing processes to become more efficient, adaptable, and responsive. So basically, AI or artificial intelligence refers to machines' ability to mimic human-like cognitive functions such as analyzing information, making decisions, recognizing patterns, and solving problems. So in an Industry 4 setting, AI-powered systems that can analyze vast amounts of data and deliver insights that would be challenging and time-consuming for humans to uncover on their own. Say, for example, AI can analyze sensor data from machines, predict equipment failures, and recommend maintenance schedules. So this smart capability enables factories to operate with higher precision and less downtime. Now, the ML is a subset of AI focused on training algorithms to recognize patterns and make data-driven decisions. So ML models learn from past data, which allows them to improve over time with minimal human impact. In manufacturing, ML can be used to detect anomalies in production, predict demand, and even optimize production schedules. So ML is especially useful for tasks that involve complex data sets. Say, for example, in quality control, ML algorithms can analyze images of products or identify defects much faster and more accurately than a human. So let's take a quick look of a few of the important applications, starting with the supply chain optimization, where AI and ML algorithms play a huge role in making them more efficient and resilient. By analyzing data from various sources, be it from suppliers, production facilities, or customer orders, invoices, the AI can provide insights into how to improve logistics, manage inventory, and plan production more effectively. For instance, AI can predict demand fluctuations based on market trends or seasonal patterns or historical data, anything. So this allows companies to align production schedules with customer demand, reducing waste and avoiding stockouts. This AI-driven optimization also facilitates better collaboration across the supply chain. Say, for example, suppliers and manufacturers can share real-time data, leading to improved accuracy in order fulfillment and shorter lead times. So in the long run, these efficiencies reduce costs and enhance customer satisfaction. Then we have the product design and customization, where AI and ML can analyze large volumes of customer data. So be it our purchase history or feedback or market trends to guide product design and customization decisions. Let's understand this by an example where AI model can analyze customer preferences and suggest design improvements for an existing product or even recommend entirely new product features. This allows manufacturers to quickly adapt to changing customer needs and stay competitive in the market. ML models also enable mass customization, where products can be tailored for individual customers based on specific requirements. So, for example, in automotive manufacturing, customers can customize various features of their vehicles, and AI algorithms ensure that the manufacturing process can accommodate these changes effectively. To summarize, AI and ML empower manufacturers to respond dynamically to both operational and market conditions. Let's talk about the big data and analytics and how they contribute to Industry 4, transforming how manufacturers make decisions, maintain equipment, and improve quality. So, in Industry 4 context, big data first of all refers to the massive amounts of data generated by machines, systems, sensors, and other devices all across the manufacturing process. Analyzing this data allows manufacturers to gain real-time insights that drive better decision-making and optimize processes. So this data-driven approach not only enhances efficiency, but also reduces operational costs by predicting issues before they become costly problems. With advanced analytics, companies can sort through all this data to find meaningful patterns and trends that guide strategic decisions. Now let's walk through some of the specific applications here. Starting with the predictive maintenance, which is one of the impactful applications of big data in manufacturing. So through sensors and data collection systems, manufacturers can monitor the condition of machinery in real time, tracking metrics like vibration, pressure, etc. By applying analytics to this data, companies can predict when equipment is likely to fail, scheduling maintenance only when necessary rather than on a fixed schedule. This prevents unexpected breakdowns, reduces costly downtimes. Say, for example, if a machine shows sign of wear based on sensor data, analytics can alert the maintenance team to check it before a failure occurs, saving both time and money. Talking about the process optimization next, analytics plays a vital role there. So, by analyzing data from different stages of production, companies can identify inefficiencies, bottlenecks, and areas where resources are being wasted. Say, for example, analytics can reveal if a specific step in the production line takes longer than others, prompting adjustments to improve flow and increase throughput. Through this data analysis, companies can make precise adjustments in real time, improving resource allocation and overall productivity. So, big data also supports enhanced quality control by continuously monitoring production data for defects or variations that might impact quality. By analyzing data at each stage of production, manufacturers can detect issues early before they reach the customer. So, for example, if sensor data shows that a product doesn't meet specific standards, the system can flag it for review, ensuring only top quality products reach the market. This data-driven quality control also enables manufacturers to identify patterns that lead to defects, allowing them to address root causes and prevent similar issues in the future. To summarize, this big data and analytics empower manufacturers with actionable insights, enabling them to make smarter and faster decisions. Now let's dive into how cloud computing is playing a crucial role in Industry 4 by providing manufacturers with a scalable, flexible, and cost-effective ways to manage their data and collaborate effectively. This cloud computing offers manufacturing companies access to computing resources, be it storage, be it processing power, and be it other applications, anything, over the internet rather than on-site hardware. The setup brings significant advantages, including scalability, flexibility, and reduced costs. So instead of investing heavily in physical infrastructure, manufacturers can tap into the cloud to meet their data and computing needs on demand. So this approach also supports global collaboration and innovation as real-time data access enables manufacturers, suppliers, and partners around the world to stay connected and aligned. Let's understand this by taking up a few applications. So collaborative manufacturing is where with the cloud platforms, manufacturing teams collaborate across different locations. This helps them, this makes possible to share and work on designs, processes, and data in real time. For instance, engineers in different countries can work on a design project simultaneously, making updates that are instantly visible to others. This not only speeds up the design and development process, but also improves communication, reducing errors and ensuring everyone has the latest information. So the cloud-based collaboration tools make it easier to work with external partners from suppliers to logistics providers, which enhances the entire manufacturing ecosystem's responsiveness and flexibility. The second is data storage and analysis. So as we discussed, manufacturing generates vast amounts of data from production metrics to machine performance and quality control data, anything. So the storing and analyzing all this data on site would be expensive and complex. But with cloud computing, it becomes cost effective and efficient. The cloud enables manufacturers to store large volumes of data and analyze it in real time to make data-driven decisions. For example, production data from multiple facilities can be collected, stored, and analyzed on a central cloud platform to optimize workflows and improve quality. Finally, one of the biggest advantages of cloud computing is its scalability. Manufacturers can quickly adjust their computing resources based on current needs, scaling up during periods of high production demand and scaling down during slower periods. This flexibility is especially useful in industries where production levels can vary greatly, such as electronics manufacturing during new product launches. Instead of maintaining costly hardware that might only be used occasionally, cloud resources can be adjusted as required, reducing overall IT costs. If I summarize cloud computing for you, this is the backbone of many Industry 4 technologies, as it provides the infrastructure needed to manage data intensive applications, be it IoT, be it big data, or be it AI. By enabling manufacturers to access and analyze data quickly and cost effectively, the cloud fosters a more connected, responsive, and efficient manufacturing environment. Autonomous robots then are a key part of Industry 4, transforming how manufacturing tasks are performed by increasing efficiency, reducing labor costs, and improving workplace safety. Let's go through what they bring to manufacturing environments and some specific applications. First is autonomous robots in Industry 4. These are the machines that can perform tasks independently without direct human intervention. By taking on repetitive, tedious, or hazardous jobs, these robots make production lines faster, safer, and more cost effective. They are designed to handle tasks with high precision, which also improve the consistency and quality of products. Another advantage is that autonomous robots can work around the clock, enabling higher production rates and maintaining a steady output even in labor intensive environments. Let's take up a few key applications here, starting with the automated assembly lines, where robots are programmed to perform repetitive and dangerous tasks like welding, assembling small components, or working with hazardous chemicals or materials, etc. So these robots increase production speed by maintaining a constant pace and they minimize errors, which improves overall product quality. By taking over risky tasks, robots can reduce the likelihood of workplace injuries, creating a safer environment for human workers. For instance, robots equipped with precise arms can assemble small parts accurately, which is challenging for human hands. The collaborative robots or cobots are designed to work directly alongside human operators. They assist humans with tasks like welding, material handling, quality inspection, especially in tasks that require flexibility and dexterity. Cobots are equipped with sensors and safety features that allow them to detect human presence and adapt their actions to avoid any accidents. These cobots are a great way to enhance human productivity by reducing the physical strain of repetitive tasks and allowing humans to focus on more complex or strategic work. Say, for example, a cobot might assist an operator in lifting heavy components, reducing fatigue and improving efficiency. Finally, autonomous robots are also revolutionizing warehouse operations, taking over inventory management tasks like picking, packing, and sorting. So robots equipped with navigation and object recognition capabilities can independently move through warehouses, identifying and transporting items to the correct location, reducing time and minimizing errors. This automation helps streamline the logistics chain, making it possible to fulfill orders more quickly and accurately. For example, e-commerce warehouses use autonomous robots to handle thousands of orders efficiently by moving goods around and delivering them to packing stations. All in all, autonomous robots are essential for manufacturers looking to remain competitive and agile. They not only reduce costs by taking over labor intensive tasks, but also create safer workplaces and ensure consistent quality.